Hello? Hello? Alright. Guess I'll wait another minute until that says 13:30, and then I'll get started.
Yeah, you can start anytime.
Oh, okay. In that case, ignore that. So, how many of you have used Python, or, sorry. I, still slightly jet-lagged, so, hopefully this will be funny. I don't know. So, how many of you used MongoDB before? Okay, good, because this is an introductory talk. I was hoping I wouldn't have everyone raise their hand and be bored the entire time. Can everyone hear me, by the way? Okay, cool. And can everybody see this? I can make it bigger if you need me to. Is that a no or a yes? Okay, cool. So this is kind of a port from an earlier talk that I did where everything was in JavaScript. One thing to know about the MongoDB system is that the shell that we provide, the common tool that we provide for interacting with the database, it uses JavaScript as its interaction language, but there is nothing about MongoDB that says really you have to use JavaScript. It just happens to be a good common denominator language. You know, a lot of us internally use Python in the company, but we couldn't make Python the primary language because it would piss off people from Ruby. Obviously, we couldn't use Ruby because then it would just suck. We couldn't use Java because that would just piss off everyone as well. So JavaScript kind of is a good, safe choice for a language to interact with a database. At least we think so. So the original version of this talk was written in JavaScript, as I said. And so I ported it to Python. And basically the only thing that I had to change was adding quotes around key names. As you'll see, a lot of the interaction with Mongo is using dictionaries, as they're called in Python. So we try to make sure that we feel native in each language. So if you look at these examples, you'll see that it looks as if you're talking to a Python API rather than you're talking in a language of a database. That was kind of our goal. Also, before I get started, a little bit about myself. I've been with 10gen for almost 3 years now, which I guess makes me a veteran at this point. I work on the core server itself, the database proper. Lately, I've been working on the Aggregation Framework, which I'll show you some examples of later. And I've done, as I've been there for 3 years, many different things, including I spent about 3 or 4 months as the Python driver maintainer. So, also, before I started at 10gen, I wrote a log analytics application using MongoDB in Python. I believe I was using TurboGears 2, if anyone has used that. I don't think anyone's used that in quite a while, unfortunately. But it worked really well, and that's how I got here. So anyway, by the way, this is IPython Notebook. I found out about it fairly recently, and it makes great for presentations. So anyway, so just going to go ahead and get started. Just a little bit of setup, just ignore that stuff. So the interesting thing here is I'm going to go ahead and connect to a database. So if you were starting to write your first Python MongoDB application, the first thing you would do is download MongoDB, the binaries, extract them, and just start running them. There's no complicated install process. It's really just unzip or untar, start up the server. That's really all there is to it. Then you would open up pymongo, import that, open up a connection. Defaults to localhost, but you can pass in host name and such. But when you're first starting out, you might as well just connect to localhost. And then you open up a database, and I'm going to go ahead and clean it out. So let's go ahead and run through these. No output yet. So I'm going to go ahead and run through how you do the basic CRUD operations with Mongo. Just if you need a refresher, CRUD is create, retrieve, update, and delete. So anyway, first thing to notice about Mongo is that our data model resembles that of a dictionary or a JavaScript object, or JSON. One limitation relative to Python dictionaries is the keys can only be strings. It's not an arbitrary type key, but typically most of your dicts will be using string-based keys anyway. So here I'm going to use the example of a blog post. I'm going to put the title, a body, and an author field, and I'm going to save it. So here what I'm saying is use that DB variable that I created right here, access the post collection. That would be similar to a table in a relational database, and save the post object. So let me go and run that. When you save something, it will go ahead and return the created ID for you. One thing to note is the ID actually gets generated on the application side rather than server side. So it doesn't actually require a round trip to generate that. Now, if I were to go ahead and print this, you'll see that save went ahead and added the ID field to that object. So if I were to go and do further operations with it, it would then be savable directly. So one thing I'll also mention is that this object ID that we generate right here, you're free to use any type of ID for your primary key. One requirement is that the primary key is always called _ID. There's no debating between whether it's ID, _ID, OID, table name ID. I've seen all of these in relational database. We just said _ID. But you do get freedom over what type you're going to create. If you don't specify anything, we use object ID, which is similar to a UUID, but slightly different. But you could use things like if you're having a user's collection, you might as well put the username as the primary key. If you're using books, you could use the ISBN number, things like that. But there's something interesting about these object IDs. And part of that is that they actually encode the generation time as part of the object ID. So you can actually retrieve that by going to the post and on the object ID accessing the generation time attribute. So you don't actually need to keep a separate timestamp field. Also, it means that if you were to sort by the primary key, assuming of course you're using object IDs again, they would actually sort in the same order as creation time. So again, you don't actually need a separate index or a separate field to store timestamps. Assuming, of course, you're interested in creation time. Now, I think in some ways what's interesting here isn't what I'm doing, it's what I'm not doing. So let me enumerate the things that you're not seeing on this screen. You're not seeing me create a table. There's no listing of schemas. There's nothing that I need to pre-declare. All I have to do is create an object and save it. And the database is able to figure out how to store this. I've gotten so used to this that when I had to use SQL recently, I'd forgotten how annoying it gets to create tables. So anyway, moving on to retrieving. The general way that you will be retrieving documents is with the either find or find one methods. And they take a dictionary again. In this case, it's field to match on and value to match. So here, if I run this, this is saying find one where _ID equals this value. So you can see that returned it. Also, you can do queries on secondary keys just as easily. So this is saying find one where author equals Matthias, or in a little bit more natural language, find me a blog post written by Matthias. And again, you can see that works just as well. Additionally, if you're looking for more than one, you can just use regular find. And what that does, it actually returns a cursor. So that can work just within a for loop. So in Python, it supports the for each protocol. In each language, we try to support whatever the language native iterator implementation is. Obviously, at this point, I only have one post. If there are multiple posts, you would see each of them in turn. Little interesting note here. Because we're using dictionaries as the data model, you don't actually need an ORM. If you just want to have things in a class type and be able to save and retrieve things from and to that class, this is a 3-line ORM. Basically, if I were to create a class called post and a class method of byId, this will populate the dunderdict method with the results of a find one, and save just passes dunderdict to save. So as an example of using this, you can see that creating post_obj equals post.byId. And if I were to print that, you can see it's actually a class object rather than just a dictionary. So now just to show an example using that, I can go ahead and modify these fields. So here I'm adding an exclamation point to the title. I'm marking .edited to true, and I'm calling save on the object, which, if you'll look here, is actually calling db.post.save. And if I were to fetch it again, you see we get the object back with the modifications in place. So the title has an exclamation point and edited is true. Again, note that I didn't have to run an alter table statement. I didn't have to go through a migrations process. You're able to add fields on demand. There's no requirement that all objects in a collection have the same fields. They don't have to have the same structure. And this is actually quite useful when you want to add a new feature to your application. One of the reasons that Craigslist is using MongoDB as its archival solution now is that previously they were using MySQL. And when they went to add a new feature to their production servers, they had to run a migration on their archival servers to add a new field to store the new information from their for this data. And that alter table statement took a month on their primary, and then once it got replicated, it took another month on the secondary, and then the secondary had to catch up to the primary again. So about 2.5 months later, they were able to start importing their data. And so they decided enough is enough. We need to look into a data store that supports flexible schema. So that's one of the advantages that you get here. Also, you can actually have more rich document structure. Up till this point, everything has been flat, but it's not really a blog if you don't have comments. So now I'm going to create some comments. Here I will say create one comment. In this case, this comment will be by Dan, telling me that I should write more. And what I'm going to do is I'm going to update where ID is post ID. So update this document and push the comment onto a comments array and increment n comments by 1. I'm also going to create a reply with an in reply to field. And it's the same pattern, pushing to comments and incrementing n comments by 1. So to print the new version of the document, you can see that we now have a it's a little line wrapping, kind of gets annoying here, but you have a comments array that goes from here to roughly here, and we now have 2 comments in that array. So unlike in a relational structure, where you would have to have a separate table for this, and to get them back out you need to join it together and things like that, instead you're able to just directly nest an array of objects directly in the post. Additionally, I didn't have to create this field again. All of our update operators try to have sane defaults when applied to fields that don't exist. For example, when you go to push onto an array, if the array doesn't exist, it pretends as if you pushed onto an empty array or created an array with just this field. Equally, if you try to increment a field that doesn't exist, it sets it to that value as if you were incrementing from 0. So that means, again, when you go to add a new feature to your application, let's say you want to add page tracking to this, all you do is in your page serving, you just say, increment where page ID equals this, increment hits by 1. And it will work even if that object doesn't have a hits field yet. Any questions so far, by the way? Okay, cool. Moving on, these are some slightly more complicated updates. In this case, I'm going to do an update where update the post ID, or sorry, update this post and the comment where the comment ID is this ID, set the matching comments text to you shouldn't write more. So this is Dan editing his comment from you should write more to you should not write more. And I'm going to do another update to the same document to pull my comment out, which will remove it from that array. So that's saying pull from the comments array all comments that match the query ID reply ID. So this is removing that document, that comment. And increment n comments by -1. That is equivalent to decrementing comments by 1. This is why we don't have an explicit decrement operator. And just to run these and print them, so now the object only has 1 comment, and it says that you shouldn't write more. Finally, one other thing that it wouldn't be a blog without is comments. So in this case, I'm going to loop through short, sweet, and stupid, 3 possible comments. And table doesn't like me. And I'm going to update the post, and I'm going to use the add to set operator. Add to set is similar to push in that it adds to an array, the difference being that add to set does nothing if that entry already exists in the array. So it's great for things like tags, where you wouldn't want the same tag to appear more than once. And it's worth mentioning that all of our update operators are atomic on each document. So that means that you don't have to worry about if you have 10,000 connections coming in, all trying to add to set or increment and these kind of operations. They're guaranteed that they will be applied atomically on each document. So you don't have to worry if you had 10,000 incoming increments, you're guaranteed that the final document will have the number 10,000. Additionally, so this is adding the tag. Additionally, I'm going to create a new collection called tags. Again, remember, collections come into existence as you put stuff in them. There's no need to explicitly create the collection. So I'm going to update where ID is tag, and I'm going to increment the count by 1. And I'm going to use this new field called upsert. And upsert is a very common operation. The idea is that it's a combination of an update and an insert. Basically, if the query matches a document, it applies the update to the matched document. If it doesn't, it inserts an object relating to the the query and applies the update. So it's equivalent to saying if there is a document where ID, let's just say I'm using the example of short. If there is a tag where ID is short, increment its count by 1. If there is no document where ID is short, create a document with ID of short and count equals 1. So you can use the same operation to create as to update. And you don't have to worry about testing for testing for the existence of that row and potential race conditions that can come up if you do the very common pattern of get it if it exists, increment, insert if it doesn't, update if it does. There's very common race conditions that can happen if you follow that pattern. So, as an example, just running through these. One other thing I'll mention, when you do a query, our query engine does something interesting when you query on an array. What it will do is it will match your query against each element of the array and return documents where any element matches. So this is equivalent to saying, find one where any of the tags is stupid, or where, equivalently, where stupid is in the tags array. There's a couple different ways to, phrase that query in English. So as an example, this is the final document. We have this array here. And as you can see, this query matches this document. And if I were to print out the tag collection, you can see that we created these we created these 3 documents. So this is what the tags collection looked like after applying that update, that operation. Any questions so far? Yeah.
There was editing in the.
Yes.
And in your presentation, the value is always true.
Yes.
Then when is it turned to the false?
So if you note, let me scroll up a bit. When I first inserted the document, there was no edited field. The edited field came into existence when I did this, once I added the edited field and marked it as true. So if you were to do a search where you said where edited equals true, it will match documents that have the field and it is true. So edited is an interesting example because there's no operation that you can do to unedit a document. Once it's been edited, you can re-edit it, but you can't unedit it, essentially. So it's something that once you've edited a document, it can never be edited false, essentially. Now, an alternative design would be to, on every document, add the edited false field. That's an equally valid design, just not one that I took, in part because I just wanted to demonstrate that you can add fields whenever you want. But both are valid designs for an actual application. All right, so I just want to mention a few things that you can do with arrays. In this case, I'm going to be creating 3 documents, ID 1, 2, and 3. And they have a fairly predictable pattern of A, B, C, B, C, D, and C, D, E. So So as I mentioned earlier, when you do a query against an array field, if you say tags equals A, that's really saying where A is one of the tags. And the only document where that applies is the first one, because that's the only one that has A. Instead, if you were to say C, that would match all three of these documents. To give you a potentially more real-world example for this, the one I used earlier, if you had an array of comments and said comments.by Dan or comments.by Bob, it would find where one of the any post that was commented on by a specific person. Or with tags, you could use tags. This is actually the feature that got me interested in Mongo 3 years ago. This was kind of the obvious case of something that was very difficult to do in a relational system, but trivially easy in a Mongo system. Additionally, we support an operator called $in, and what that's saying is, it's similar to in SQL, it's saying either of these two values. So that's saying where tags has either A or E in it. And so that is this document and this document, but the middle document does not have either A or E. All is similar to in, except all is saying has both, or has all of these. So if you were to think of in as an or, all is an and. So this is saying has all of A and E, and there are no documents that have both A and E. But if you were to say have all of C and D, 2 and 3 would match. Some of the other interesting things you can do, once you do the query and you have the documents, there's a second parameter defined. I've been leaving it out up till now, but it lets you select which parts of the document you want returned. You don't always have to get everything. By default, we do the equivalent of a select star or return the whole document. You can also use the second argument to say return just these fields. Additionally, you can slice an array. So you can say give me the first element or the first two elements. You can do Python style and say -1 or -2 to say give me the last one or the last two or the most recent comments. This would be a way to do pagination. And you can also do ranges. So you can say, this is actually slightly different than the Python syntax. This is saying offset of 1 and limit of 2 rather than up to 2. But so that says give me two documents starting at, or two elements starting at position 1. And you can also do updates. So what this is doing is setting all B. So this is saying where tags is B, update the matching tag to capital B. And if I run this, you can see that it's gone ahead and replaced these examples. So that's the basic CRUD operations. I want to mention a little Python library that I wrote. It's on GitHub. So it's called Mongo Magic, and what it does is it allows you to write queries in a Python style syntax. So in this case, it imports the magic variable m. The m you can think of as Mongo or magic, or Mongo Magic. And it lets you just tack on variable names. So this is saying comments.by and then use Pythonic equals Dan. And you can use that as a query. So you can see that when I print this statement, using the magic of operator overloading, actually becomes this expression. And so if you were to do db.post.find1 and then use a, this comparison expression, what looks like a comparison expression in Python, you actually get back the document you were looking for. Also, one of my favorite features in Python that has been copied by far too few languages is the between syntax. The ability to do both greater than or kind of say that m.comments is between 0 inclusive and 10 exclusive. I don't know why more languages don't support that syntax. It's very clear. But since I like it so much, I decided to support that in Mongo queries as well. So this is how you could say db.post.find1 where the number of comments is between 0 and 10 in a nice Pythonic way. Any questions? Cool. So this example uses something that we have in the US called zip codes. I don't think you guys have anything exactly similar. It's kind of like a chome, I think, but kind of bigger, and they're numbered in a way that's unique across the entire country. I don't think you guys have anything similar, and that's the best I can do to explain it. But anyway, there's this there's a data set that I got a hold of. It's a little bit out of date now, so these numbers are going to look a little bit silly. I think it's about 20 years out of date now. But it's kind of an interesting data set to play with because it has, for each of the roughly 30,000 zip codes in the US, it has the number of people that live in the zip code, the location of the zip code in latitude and longitude, and the city and the state. Let's see. So, do any of you do applications that care about where things are, do geospatial queries, or, for example, using the Foursquare, find me all bars within, half a kilometer from here? Does anyone do any work with geospatial data sets? A few of you. Okay. So, just going to show a little bit that you can do with Mongo and geospatial. So, this is using a tool called Mongo Import that takes a JSON file and imports it directly into the database. And so now I have the 29,467 zip codes. I will then build a two-dimensional index on location. And just to show you what these objects look like, there's an ID, there's a city, location, population, and state. Location is longitude, latitude, or XY, depending on how you want to look at it. So as an example, if I wanted to find zip code 10011, which, by the way, is the zip code for the Tengen headquarters, it has a very easy to remember latitude, longitude, which is why I like it. It's almost exactly -74 by 40.74. Anyway, so now what I'm going to do is take that as our location. I'm standing at exactly that position. And I say find all zip codes near me. And the way you do that is you say db.zips.find location $near location and limit to 5. So find me the 5 closest zip codes. And that's really all there is to writing a geospatial query in Mongo. It's really just $near is the basic operator to use here. So the 5 closest are obviously our own zip code is the closest, and there are a few others that are close. There's also a command that you can run that will give you a little bit more information, including the distance. But one thing to note is that the distance is in the same units as your input. So that means this is a number of degrees, which is kind of a useless number for most cases. Now, if you're, say, developing a game board, and you want to say how many squares away, perhaps that'd be useful. In fact, there are a few online massively multiplayer games that actually have their squares represented as a MongoDB two-dimensional index, and to find where things are, we'll use that same system. But since most of us are interested in queries on the real world, we support a spherical geometry. And so what this is saying is, assume the world is round, which, usually a good assumption. And also, you can say which units you'd like your results in. We don't have a preference of kilometers or miles. We use radians internally, which is equally inconvenient for everyone. So if you want to get a useful number out, you'll need to multiply it by radius of the Earth in your unit of choice. One of the fun Google hacks is that if you Google for radius of Earth in kilometers, it will tell you that. You can also do things like Armenian cubits, if you're interested in obscure measurements. Anyway, so if I run this query, you can see the distance of our zip code is about 40 meters. The centroid for the zip code is about 40 meters from our location. The next closest is 0.8 kilometers. And you can see that we actually show it in increasing distance. So if you're trying to develop a site that will say, show me all bars and list the bar name and location, it would be very easy to develop on top of this. A few other operations that I'll mention for geospatial. We support within operations where you provide a shape, and we support querying for all things within that shape. Currently, there are 3 supported shape types. A box, where you provide corners. This would be what you would use if you wanted to show pinpoints on a Google map. You can also do a center and a radius. So this would say, this would be find me all bars within half a kilometer of my location. And you can also tack on other query parameters. It's not just a geospatial query. You can also say, find me everything within half a kilometer that's not in New Jersey. So this is actually doing a count. There are 310 zip codes in this region, 537 within half a degree, of which 300 are not in New Jersey. All right. I will mention Mapreduce very briefly. It is a way to do the equivalent of a group by or an aggregation query in MongoDB using JavaScript functions. It's not nearly as complex as it sounds, but it's not the most convenient thing in the world. As you can see, it involves writing JavaScript functions inside of Python code, which, not the cleanest way to do it. It's not that bad, but it's not great. Also, it's rather slow. So just as an example, you can see it took maybe half second. As they get increasingly more complex, they start taking increasingly longer. This one's going to take a few seconds, actually. So you can do some pretty complex aggregations. These are rather simple ones. This is doing the equivalent of getting a sum, getting a count, the number of zip codes, getting the total population and the average population of zip codes in each state, or sorry, in each city. So it's a rather, it's not very complicated to write. Once you've written a few of them, they're all kind of the same. But it's not the cleanest solution. It's kind of slow. So as I mentioned, the thing I'm working on now as the primary maintainer of is the new aggregation framework. And the goal here was to do something that's more declarative in nature. You're not telling it necessarily how to You're not writing code, you're writing a declarative syntax. But the idea is that it's not the same as SQL, it's a different mindset. How many of you have used Unix pipelines? Things like sed, cat, awk, grep, these kind of things. So you know how it's a bunch of very simple tools. Each tool by itself can do a very small thing, sometimes with a dizzying array of options. But each tool is a little piece. But when you stack several of them together, you get very powerful output. So you can do a lot with it because you can chain things together. So our new aggregation system is taking that mindset. So we provide a couple of basic operators, such as a filter, a grouping, a sorting, a limit, which is the equivalent of head or tail. We provide a lot of these similar tools, and we let you stack them on top of each other. So take the output of one, send it to the next, and so on, just like a pipeline. So as an example, there's this SQL statement. So this is this is actually the same as the last Mapreduce. And what I'm doing here is I'm saying group on the ID is the grouping key. So group where ID is pull out the city and the state. Count is the sum of 1, so add 1 for each document. That's how you get a count. Total population is the sum of the population field. Average is the average of the population field. So then match where the ID.state field is New York. You could also say where total population is greater than 1 million or any of these operations. Sort by total population in descending order. And limit it to 5. So this is find the 5 biggest cities in New York. That's the way to phrase this in English rather than programming. And we're going to send that to the aggregate command. So just to run this, as you can see, it ran much faster. And you get your results back where, so you can see Brooklyn has roughly 2.3 million people with 37 zip codes. New York, which in this case means Manhattan, has about 1.5 million and 40 zip codes, so on. But now you can get things more interesting. So as I said, it's a pipeline. And to do interesting things, you just add more stages in your pipeline. So here, this is going to group into cities and give me the number of zip codes and the total population of that city. And then I'm going to group these cities into states. So this is grouping on the ID.state field of the output. And so if I count the number of inputs, that's going to be cities. If I sum up the counts, that's going to be the number of zip codes in the state. I can also get the total population of the state and the average population of the state. Again, I'm going to sort by the population and show 5. So this will show California as the biggest, with roughly, California is the biggest with roughly 30 million people. And an average population, each city has an average of 27,000 people. And so on. The 3 biggest being California, New York, and Texas. So getting, as I said, getting increasingly more complex. Let's take just New York, California, and Texas. So match on those states. This is the equivalent of a grep. Group, again, city, states, same building block. As you can see, you can reuse these building blocks. One thing to note, this is just an array of dictionaries in Python. You can easily build these up programmatically. Has anyone tried to build up group by statements programmatically? It's just something you don't do because there's no good way to do it. One of our goals here was to use data types that are usually worked with in programming so that you can build them up programmatically. You can write a GUI that will let you say, drag the group by cities operation in and grab these things. So you can build up these kind of complex reports on the fly. You don't need to pre-write all of your aggregations. You can build them and allow your analytics people to combine them and actually build intelligence from your data without having to call in a programmer to write a new aggregation system. So anyway, this one is going to group by the zips into cities. I will now sort the cities by population, putting the smallest city first. And then I'm going to group the cities into states. And I'm going to make use of a few new operators this time. This will get me my biggest city, the population of the biggest city, the name of the smallest city, and the name and its population. So using the first and the last operators. So this is going to tell you that the biggest city in New York is Brooklyn, the smallest is Rockette Lake, the biggest in California is Los Angeles, the biggest in Texas is Houston. And just, that's not the prettiest object to look at. Let's reshape it a little bit. This is using the projection operator. What this is going to do is, in addition to grabbing all of these fields and just passing them through unmodified, it's also going to take biggest city and create an object with a name and a size. Also, I'm going to compute the portion of the state that is contained in that city. So that is dividing the biggest population, the population of the biggest city, by the total population of the state. And as you'll note, this is taking the pipeline array. As I said, you can build these programmatically. This is just pushing this object onto an array. So here, unfortunately, it's wrapping in an annoying way. But so this is telling you that Brooklyn is roughly 13% of the entire New York state. If I scroll down, Los Angeles is roughly 7% of California's population. And you can see it's building up these objects and creating these complex nested objects. So it lets you do some interesting analytics, and this was starting from just zip codes and just using a few tiny operators that let you build up to these complex analytics. Would anyone like to try to write that in SQL? I don't think it would be fun. We've tried a few times and we haven't found a satisfactory way to do this kind of query. And yet it's just it's rather intuitive how you would build these pieces by just stacking them together. So that's the new aggregation framework. That's what I work on day to day. And this was all written in Python. So it's very easy to attack these problems in the language of your choice. Any questions? I think I might have a minute or two. Yeah?
You mentioned about the geospatial index.
Yes.
What index technology are you using?
So it's actually, it's using our normal B trees, but we actually use a clever trick with geohashing. What we do, and this is getting a little bit technical, but since you asked, let me scroll up and you can actually see it. So what this is this is actually interleaving the bits of the x and the y coordinates. So this is kind of taking the x and the y coordinates and interleaving their bits. Yeah, it's also known as a Z space filling curve. There's a couple names for it. But the cool thing that lets you do is that it lets you subdivide space by taking prefixes of these bits. So if you take the first 2 bits, that divides your space into quadrants. If you take the next 2 bits, that divides your space into quadrants, then divides the individual quadrants into quadrants. So you can see how, and taking these prefixes, I don't know how much you know about indexing technology, but it's very easy to convert from a prefix into a range query. So that lets us use B trees in a way that lets you just do a range query to find a subtree. So that lets us convert from a square in space or on a map into a range query that you can very easily index. You can query with polygons. You cannot currently store polygons, but that is a planned feature. I think it's in the 2.6 timetable, but I'm not entirely sure on that.
Have you considered to use Artree or Artree?
We've considered Artree. The interesting thing about using a Z order embedded in a B tree, again, this might be too deep off the CS diving board, but the interesting thing about using Z order inside of a B tree is that it gives you an implicit quad tree. You actually query it as if it were a quad tree. So it's basically the same, just not physically a quad tree. Quad trees are actually kind of hard to work with in a database, just the raw structure of them. So, but an R tree, it's something we've considered, but we're not sure about yet. The nice thing with this was that it was able to be implemented in a few hours. So it was a very easy add to our base functionality, at least the initial version. All right, I'm going to be here today and tomorrow and possibly the next day. So if you see me and have questions, feel free to ask me. Thank you.